Section 1.5, combinations of functions. These are the 5 different combinations of functions we're going to be talking about: addition of functions, subtraction, multiplication, division, and composition of functions. Now, when you see functions written in this manner, take the time to rewrite it in what I'm going to unveil here on the right side of each one of these equations. It's going to make much more sense to you exactly what it is you need to do if you take the time to rewrite it. A lot of you aren't going to do that, and you're going to be confused about what you're plugging in where and things if you do not take the time to rewrite this. So f plus g of x is the same thing as just taking f of x and adding to it g of x. F minus g of x is the same thing as taking f of x and subtracting g of x. F times g of x is the same thing as taking f of x times g of x. And f divided by g of x is the same thing as f of x over g of x. So I think you can see on the right side, it's going to be very clear what we're going to do. Sometimes if it's written the way it is on the left and you don't take the time to rewrite it, it's not going to necessarily be so clear to you as far as what you need to do. F composed with g of x is f of g of x. So again, I encourage you to rewrite each expression as it is on the right before you worry about evaluating anything in the homework problems. Okay, so looking at our first example here, given that f of x is x squared plus 2x, g of x is 2x plus 1, evaluate f plus g of x. Well, remember that is just f of x plus g of x. So now what do we need to do? Simply take f of x, which is x squared plus 2x, add to it g of x, which is 2x plus 1, and simplify. We get x squared plus 4x plus 1. F minus g of x. F of x minus g of x. So what do we need to do? Take f of x, which is x squared plus 2x, and now this is where you need to be careful. You're subtracting off all of g of x. So I'm subtracting off 2x plus 1. Like terms, the 2x's are going to cancel out, and we're just left with x squared minus 1 when we distribute that negative through. Part C, f times g of x, or f times g of x, remember, is just f of x times g of x. So I'm going to take x squared plus 2x, multiply it by 2x plus 1. We need to FOIL this out. We get 2x cubed plus x squared plus 4x squared plus 2x. Continue adding like terms. We end up with 2x cubed plus 5x squared plus 2x. So not very difficult to do these different combinations, but make sure you rewrite it first before you worry about what it is you're trying to plug in. I think it will make the problems much easier. Continuing here, letter D. Find f divided by g of x, then find the domain of the function. Well, f divided by g of x, remember, is just f of x over g of x, which is going to be x squared plus 2x divided by 2x plus 1. So there's what our new function looks like. Now we are asked to find the domain of that function. Well, remember, we have 2 possibilities for domain restrictions: variable underneath an even indexed radical, or a variable in the denominator of a fraction. Those 2 things could cause us a domain restriction. In this case, we have a variable down in the denominator, so I want to take what's in the denominator, set it equal to 0, solve that, and we know x cannot be negative 1/2. So what does our domain look like? Well, x can be anything but that value. So negative infinity up to negative 1/2, but we cannot include that. Union with the interval beginning right away again at negative 1/2 and going out to infinity. Letter E, f composed with g of x. Again, rewrite it. That's the same as f of g of x, which means we are taking g of x, always start with the inside function. What's g of x equal to? 2x plus 1, and we're plugging it into the outside function of f. So when we go to plug that in, that is just f of 2x plus 1, which means now into our f function, I need to put in 2x plus 1 every place we had x. So we're going to have 2x plus 1 squared plus 2 times 2x plus 1. This first one becomes a FOIL. Remember, anytime we square a binomial, it is a FOIL. When we FOIL that out, we're going to get 4x squared plus 4x plus 1. Distribute here, we get plus 4x plus 2. Finally, collect like terms. We end up with 4x squared plus 8x plus 3. And now the composition in the other direction. G composed with f of x. That's the same thing as g of f of x, or g of, what's f of x equal to? X squared plus 2x. And now we're taking that and we're plugging it into our g function. So in our g function where we had x, I'm going to put in x squared plus 2x. And now simplify that. Distribute, we get 2x squared plus 4x plus 1. So you can see here that it does matter the order in which we take a composition. When we take f and compose it with g of x, as we did here in letter E, we get this function here. When we take g composed with f of x, so we go in reverse, we get this function here. Okay, so you don't necessarily get the same function. So don't assume that compositions of functions is commutative, because it is not. Okay, last one here. Given f of x is x plus 2, g of x is 4 minus x squared. Evaluate f composed with g of x and g composed with f of x when x is 0, 1, 2, and 3. So again, we need to go both directions here. Let's start with f composed with g of x. F composed with g of x, first of all, remember, is f of g of x. Now we need to evaluate that at each of these values, 0, 1, 2, and 3. So I'm finding f of g of 0. G of 0, plug 0 into my g function. We get 4 minus 0, which is 4. So now we're evaluating f of 4, plug 4 into the f function. We get 4 plus 2, which is 6. Find f of g of 1. So I'm first finding g of 1, plug 1 into our g function. We get 4 minus 1 is 3. Now f of 3 is 3 plus 2, which is 5. F of g of 2. Plug 2 into the g function. G of 2. 2 squared is 4. 4 minus 4 is 0. So I'm finding f of 0, which is 0 plus 2, which is 2. And the last one, f of g of 3. G of 3 is going to be 4 minus 9, which is negative 5. Plug -5 into our f function now. We get -5 plus 2, which is 3. I'm sorry, -3. Now we're going to do the exact same thing, but we're going to compose it in the opposite direction. So I'm going to do g composed with f of x. Remember, that is g of f of x. So the first one I'm finding is g of f of 0. F of 0. Plug 0 into our f function. We get 0 plus 2. So that's g of 2. Plug 2 now into our g function. 4 minus 4 is 0. G of f of 1. F of 1 is equal to 1 plus 2, which is 3. G of 3 now is going to be 4 minus 9, which is -5. G of f of 2. F of 2 is going to be 2 plus 2, which is 4. Plug 4 now into our g function. 4 minus 16, it's -12. And finally, g of f of 3. F of 3, 3 plus 2 is 5. G of 5, 4 minus 25 is -21. So for all these problems, the arithmetic things involved isn't going to be difficult. It's going to be wading through exactly where it is you are plugging into, what function you are working with. Again, take the time to rewrite them in a form that is more useful to you.